quantify, kind of to illustrate a little bit with a small computational model. And in that small computational model, I will use a two-stage model. I have producers, I have generators. Both of them are risk averse. It's in the first stage, the generator invests. In the second one, he produces. In the first, you can also sign contracts with the consumer. And in the second stage, we clear the financial contracts. So it's a bit like a risk-averse equilibrium model, a stochastic equilibrium model. I give an idea just to explain, to give two benchmarks for that. I will show first a market where everything can be hedged. So this would be a complete market which is physical, which is in the real world almost impossible to achieve. And then we have the case where no trading is possible. On the lower axis, you see like risk aversion moving from left to right, increasing. The model is calibrated on a country like Belgium, so the numbers are in billion euro. On the very left, if nobody is risk averse, completeness doesn't matter because people don't care about risk. But if risk aversion increases, the two start to deviate. The reason why they deviate is essentially in the ability of investors to make investment decisions. The investors essentially balance risk-adjusted future profits against investment costs. Those have to be equal. Now, if I can't hedge, essentially I need a high amount of high return scenarios to make sure to balance out the bad scenarios. So here we use coherent risk functions, which are usually used in finance to adjust from a physical probability to something that is a risk-adjusted probability. Essentially what you see is as an outcome of an equilibrium calculation is that if I can't trade, I underinvest in a certain number of scenarios, prices are extremely high, in some others prices are, I make big losses, so this is the upper level. On the consumer side, welfare is high, if there's enough capacity, welfare can be very low if there's not enough. So essentially I have rather contrasted and extreme scenarios. If I have complete markets, I essentially reduce the required revenue for the investor because I give certainty to the investor. So the risk-adjusted return per investment becomes the same, but the amount of investment increases substantially. And that is also in the benefit on the consumer. So that's like the basic idea of translating the Newbery-Stiglitz paper to a power market. Now, the question is, completeness we cannot have, but we can have maybe something simpler. We can have maybe a base load contract or a yearly forward contract. So what happens if we move to a system that is only partially complete? And if I have only a partial complete market, I can see that again in this two-period model, that in fact, if this is fully liquid, even a single contract, a base load contract, can bring us to a point that is actually not that bad. It's not far away from the welfare that a complete market would give us. However, the amounts of trades that are necessary to get that are far beyond anything we have seen in any European market, especially if you think of the second stage being more than maybe 2-3 years out in time. Now, if we reduce the liquidity of those products to maybe 100% of the energy, which is still a lot, then the value of that drops rather quickly and quite dramatically. And essentially we start to lose a lot of the benefit of that, which essentially means that even this is based on a perfect short-term market, it might still create a difficulty if you cannot have the hedging product. Now Bert gives me a sign to conclude. So I will sum it up a little bit. The economists have pointed the importance of risk trading quite frequently and quite oftenly. I think that applies importantly for the power markets and essentially on the side of the operation, but also on the level of the investment. I think for the short-term market, it's clear that the US system is superior in quite a few different things. Nevertheless, it is a little worrying that FERC didn't like to have those products. Essentially, you could argue that the more ramping products become relevant in the short term, the more virtual trading possibilities you should have. So you might actually have to explode the number of virtual trading possibilities just to have the market complete. How many you need, that is something that you need to calculate, but probably you need to do more. If you want to have the same kind of additional services like ramping in the European system, it will become a little bit more complicated. Maybe we can move to something like combinatorial auctions to deal maybe with 1 hour ramping, 2 hour rampings and try to balance them out and to mimic co-optimization. But it will be very difficult to do for the market participants. And in the end, if you're lucky, you get close to something like a co-optimization. Now, whatever efficiency you achieve on the short term, I think it's equally important that the benefit of that needs to be transferred somehow to the investment stage. And one should not take for granted that that happens if those forward contracts do not emerge from the market. And at least in Europe, they have not emerged from the market so far. So I think it's something we need to pay attention to, and we need to enforce that. Because again, the short-term market is important, it's the right thing for the short term. But as an investment signal, to get a result that shows short-term efficiency leads to long-term efficiency, you also need financial contract for the long term. Thank you.
Good morning, everybody. First of all, let me say that it's really a pleasure to be here today. And I'm Clara Poletti. I work for the Italian Regulatory Authority, so I'm the person that is going to read what you write and try to understand how to make the best use of the literature and design, help designing good markets. So I'm here to learn. But I'm here to tell you as well what type of issues we as regulators are facing when addressing questions about the market design. I come from a country that has been trying to launch a capacity market since 2003. At that time, we had a blackout. We had shortage and adequacy problem, but then the capacity, additional capacity was built. Now we had excess capacity for quite a long time, and we still have been trying to launch a capacity market. We are back with some adequacy issues, and we are still trying to launch a capacity market. So that to give you an idea that we have been thinking that the short-term price was not enough in order to give the right price signals for investments for a long time. This doesn't mean that we don't believe that the first aim is to get the short-term price right. We have been trying to do that as well. So I want to ask you a question. Were you convinced by the Professor Hogan's story about the competitive market design? If so, I was. I personally was. I buy it. I buy your story. But then I ask myself, is this first best description what we have today? So can I work within that framework today? Because if not, if the answer is not, it means that I have to find a sort of fix for the second best. I think in Europe, for sure, the answer is not. But maybe in the States is yes. I don't know, I don't judge. But in Europe, the way the market design and the target model has been addressed is completely different. And here I want to make clear that I'm not presenting the positions of ARERA, the Italian Regulatory Authority, neither of Acer, just my personal opinion. So, as I said before, I fully agree that we have two questions on the table. The first one is on short-run efficiency, and the second one is on long-run efficiency. And many things have already been said by Andreas, so thanks, I will be able to go fast on many things. So the theory, the first best is a centralized optimized unit commitment and real-time dispatch to achieve an efficient welfare maximizing outcome. And this is something that many markets in the world have been trying to design. And what about Europe? Europe has not been following this path somehow. We started from day-ahead markets, sort of leaving aside the real-time. We have extremely poor locational signals for balancing intraday and even day-ahead prices. You know that in the clean energy package proposal, the definition of market zones should be left to member states at the end. It's not even recognized as a technical issue. It's more of a political issue. And in fact it is, because the way you design market zones affect the price that final customers are going to pay. So we had sort of a political interference there when designing our locational price signals, plus many other imperfections I don't want to list. On the bidding side, the short-term bidding, in theory, market players should truthfully bid their short-term marginal cost, but here we know that we have an elephant in the room that is market power. And market power is a big issue in electricity markets. In the US, some ex-ante mitigation measures on bidding have been implemented. In Australia as well, some cumulative price thresholds. In Europe, we don't usually have those type of measures. We have free biddings, monitoring and control on market manipulation, but market power is hard to identify and mitigate, and my feeling here is that we have been using market powers implicitly in order to pay for capacity sometimes. Because the first best we heard about means that you have short-run marginal cost as a market price until you get to the scarcity, and then, boom, the price goes up. Is this the type of market we are seeing? No, I don't think so. You see the price going up at different times of the day for different reasons, and often because of the way the market, the electricity market functions, you have some exercise of market power even a lot of time before the scarcity arrives. On the co-optimization, in theory we should have co-optimized energy and ancillary services in real time to ensure system reliability. In Europe, again, reserves are not co-optimized with energy, and many member states still count on long-term procurement of reserves, and strategic reserve and congestion management are often kept out of the market. There is a preference for a strategic reserve type of solution, which is a sort of set aside. Let's set aside some capacities so that TSOs will be able to manage in real time the system and leave all other capacity free to bid in the market. Is this efficient? I don't think so. This is far away from co-optimization. On long-term investments, I don't think that short-term price signals can solve all the problems about long-term investments, but here I'm going to refer to Andreas. I think he just explained it very well. And having said that, even in the first best solution, probably, if there is some risk aversion, the cost of capital could be too high if we rely only on short-term investments. In Europe, we are not there. We don't have this first best short-term price structure. Trying to get there, allow for scarcity pricing, but some member states consider that capacity remuneration mechanisms, market-based, are a solution to ensure adequacy. And the ORDC is under consideration in some countries as well. So in Italy, what did we do? As I told you, we tried to launch a capacity market since 2003. Now we have, our capacity has been approved by DG Comp under the state aid procedure, and so we should launch it. It has taken 15 years. I wouldn't say that the ORDC is simple because it took 9 years, but maybe simpler than this one, I don't know. The type of market we are having, first of all, is not a subsidy. Because many times when I go to conferences, capacity market is another way to say subsidy. It's not a subsidy. The price can go to zero if the capacity in the market is high enough. The auction price could go to zero. The demand for capacity is elastic and the design is technology neutral. Demand depends on the same variables that Professor Hogan was mentioning. As Andreas was saying, capacity market is a long-term view or version of the ORDC reserve. The scarcity pricing is still there. We want to get the scarcity pricing right. So capacity market is not a substitute for scarcity pricing. You need the scarcity pricing there. And on good short-term price signals, you can build a longer-term market. The Italian capacity market maybe, is a pay for performance. Generators have to give back the difference between a reference price, which is the market price, and a strike price, which is the variable cost of a gas-fired power plant, our marginal power plant. They get a premium for that in exchange, so it's a sort of one-way contract for differences. Is a real option. They have to bid in both in day-ahead markets and real-time markets, so that if they are not there, they are not available at time of scarcity, they have to pay back the difference between the value of lost load and their variable cost. So there is an implicit incentive to be in the market. The demand can take part in the market and also foreign capacity. The demand is, we don't have double payment for demand, and demand is still exposed to scarcity pricing as well. So we try at least to learn from that. I think my time is over, so I want just to ask a question. How can we ensure that the right portfolio is generated either by capacity markets or any other market? Because Professor Hogan, you said that even with renewables, we can rely on the same marginal price system, but I think the equilibrium will not necessarily bring to the right or desirable generation portfolio if we look at the renewable side. So when you start or overlap some incentive mechanism and planning for the deployment of renewables, you are saying renewables deserve a longer term view in the market, whether other generators or the demand side or storage, they don't. So it's not clear to me how to match these two perspectives. Are we going to say that even renewables, they should react to short-term prices? Are we going to get there? But, I think we need to rethink about general market design where renewables are not supported by incentives anymore, and ask, is it sustainable just to have short-term prices? Thank you.
Okay, so thanks for three very nice presentations. So we have some time left for discussions with the whole audience. So I thought I would put up some three statements, and those three statements are not necessarily representing my personal views. So I will turn it around a little bit. And I think that might be some of the statements that could be used in the discussion. So the first statement is that in most markets that we have in the world, short-term prices do not correctly reflect the cost of reserves, or not reflecting the true value of the power. So maybe the taxes system comes close, but we haven't tested the system, so even there we don't really know. Second point is that capacity markets are not a remedy for inefficient short-term prices, so we should really get them right. And then the third point is that even with efficient real-time prices, there might be other market failures like incomplete financial markets that maybe means that we still need some additional regulatory instruments like a capacity market. So that's just three statements that you can keep in your mind when you raise some questions. So I will now try my throwing skill. Let's first see whether... okay, so who would like to start with some questions? Okay, so are you ready?
Okay, does this work? Is it on? Good morning, Feridun Sirshansi with Menlo Energy Economics. Thank you all three, very, very interesting, provocative. I have a question mostly directed at Professor Hogan. You talked about the California's energy imbalance market as an RTO without being called an RTO, essentially. Is that your vision, that it's evolving into a broader market with many of the features of an RTO without being regulated by FERC? Is that how you think it's going to evolve? Thank you.
Hello. It's a lot of this is optics. So the energy imbalance market is regulated by FERC, but it's not an RTO. And they're not going to call it an RTO because an RTO carries with it many, many, many other issues that have to do with governance and long-term planning for transmission expansion and all these other kinds of things. And so the energy imbalance market is evolving. It is not explicitly to be characterized as being an RTO, but it is regulated by FERC. And that's being as a subject of active discussion right now. Now, what's happening because of the energy imbalance market is, in fact, all of these parties are having parallel discussions about actually just going all the way and having a formal RTO. This is going to take a while, not the least of which is because of the governance problem, because right now the California governor appoints the board of the California ISO, and that's not acceptable, obviously, to the rest of the parties in the West. So they're going to work that out. They will work that out. Eventually, that'll happen. Then it'll be essentially at least one and maybe more new organizations that'll evolve in the future, which they're talking about as we speak. But the critical thing, which is the real time, is happening because they can't wait.
Carsten Neuer of DAW Berlin. You've discussed two elements, and I wonder whether one needs to discuss them separately. For the flexibility options, existing assets, I think the functioning energy-only market is essential to get the incentives right, and we struggle to define capacity markets to address them. For the renewables, we've got a political set objective what you want to have, and Andreas showed very much the challenges of financing this without long-term hedging, and at the same time it's very difficult, particularly for renewables, to define in the market-based long-term hedging contracts. So do we not need two elements together, functioning energy-only markets for the flexibility and long-term public guarantees on the hedging side for renewables, rather than an integrated solution that tries to do both at the same time?
Well, I guess this is a little bit what we have today, because the renewables that are financed by auctions or feed-in tariffs essentially have a long-term contract with the government. So essentially they have that. Now the difficulty is a little bit, I guess, that if you is about the share of what is left decided by the short-term market outside of the long-term contract that is given with the government. And obviously also a small market can still give meaningful price signals, but especially a small market gets even more volatile or more vulnerable to small changes of any form of intervention. So I guess then the question of hedging on the residual market might actually become even more important.
Sorry, can I just integrate the answer? Just to say that I think what we are asking for in a capacity market is availability of capacity at the peak. So this is a product that renewables hardly can give you. So the type of design, we could try to integrate the two, but we should change the design of the product, because renewables, they give you more, at least today, maybe not in the future because of storage or whatever, or new technological innovation. Today they give you energy. In the capacity market, you ask for capacity at a given point in time. So I don't have the answer, but maybe it's possible to work on both of them, but for sure I agree that now we are giving long-term view to the renewables, and the question is, can we do without for the others, or can we do without for renewables as well?
Was it my turn already? Thank you. Very nice talk and good discussion. Marilyn Brown from the Georgia Institute of Technology, and also 8 years as a regulator of the Tennessee Valley Authority, which is a very different public power model, one of the largest systems in the United States. And I wanted to mention, of course, one of the problems that all markets and all electricity systems have is to try to foresight of technology and demand. Right, so who would have thought that at the time that Bellefonte was built or being built, natural gas prices would have dropped so dramatically with hydraulic fracturing and horizontal drilling? Who would have thought that energy efficiency demand and innovations in that market would cause the demand for electricity in an entire system to turn flat, having for decades grown at 2% per year. So put in perspective then the concept of completing the Bellefonte plant when no new power is needed. It was the correct decision. I was the chair of the Nuclear Oversight Committee at TVA that made the decision to close the plant. At the same time, we did complete the last commercially operational nuclear plant in the United States in December of 2016. A 1.1 gigawatt plant was built. The public power model can be a very good one. At TVA, Tennessee Valley Authority, we've reduced our carbon emissions by 50% since 2005, put in place a lot of renewables, a lot of gas, closed a lot of coal, and completed new nuclear. I'm always surprised when I read the markets literature, the government, U.S. government assessments of the state of the electricity, doesn't pay much attention to the Southeast. We didn't have problems with the polar vortex when it hit markets across the U.S. We were very well prepared with reserves, integrated reserve capacity and energy markets within a single system. So what do you think about public power as an alternative to Texas ERCOT as the next utopian approach? Thank you.
Okay, so I mean, it's maybe slightly a bit off topic, but maybe some people want to react. I mean, to the southeast.
Well, I think public power has slightly different institutional structures, slightly different incentives, but it's run by people, and they're using the same technology, and they're facing the same uncertainties. So I think the same fundamental analysis applies there. Now, if you had historical access to cheap credit and lots of other things, and you built too much capacity, you're going to look pretty good after the fact, but it's quite expensive. So public power in the Northwest, that was a public power operation, which was the largest public power bankruptcy in the history of the United States when it actually happened. So I don't think there's a fundamental difference between the two there.
Those regions both have the lowest power prices in the United States, the Northwest and the Southeast. Despite, anyway, thank you.
Okay, so more questions? So, I mean, if there are no questions, we could go for some drinks. Okay, I didn't see that, so live. So, okay, let's take one more question on the back there.
Okay.
Okay.
Okay, I was just going to ask a quick question. There was no discussion of sort of contract for differences, where you could allow the generators to sign some sort of contract, long-term contract with the distributor as a way of handling this investment problem. I was wondering if you wanted to have any comments on that.
Yeah, I guess maybe that's more Andreas, because you were mentioning a lot of or Clara, I don't know. You can vote maybe.
Well, I mean, I only showed here a result for a standard-based contract. One can do the same thing, or we have done the same thing in the accompanying paper with a number of different types of contracts. The difficulty is always to find a credible counterparty for a duration that is actually long enough. And that is not necessarily easy. The load-serving entities in the US, I mean, some jurisdiction might not have retail competition. You might be able to oblige them to sign a 3-year contract. In Europe, you cannot do that. The suppliers will not engage in something like that. On the industry side, you will always face the difficulty that, I mean, a 20-year contract with the industry, I think there's only one that has ever happened, which is the nuclear power plant in Finland. So I don't think that those are realistic to see. But if they are not there, then at least one has to be a little bit more careful.
I think one of the effects of liberalizing the retail market is that this vertical integration between generation and supply has been disrupted. So we are left with the problem of hedging long-term, how to hedge investments. The solution we designed in Italy is a contract for difference. It is a reliability option, a one-way reliability option, real option, but the counterpart is not the market, because the market, in our view, will not be willing to sign that type of contract, first of all, and secondly, this centralized way of is more efficient, because in theory, at least, the TSO should buy the right amount of capacity using an elastic demand. So depending on the price in the market, you'll choose the level of adequacy that you want to buy. So this is the solution, at least, that we have been trying to implement.
Okay. So, so we will also organizing a bit later today the roundtable on market design. So if you still have questions, so then people really want to know more or want to participate in a discussion, we will be organizing this roundtable, so you can check your program book. So it's in room 14, somewhere, going up and then stairs up, but you will find your way. So then I would like to thank again all the 3 speakers, and then we can, Okay, and enjoy the rest of the conference.